Sounds good.
Okay, hi, welcome to this Open Security Summit session in May 2022. We have Or here who's going to present us on a really, I would say, key topic because it's about access control at scale, and this is one of the areas that in security that if you really want to enable the business and allow the business to operate at maximum speed without being, the Department of No and being the Department of being enabling, this is one of those key areas that is very hard to get it right, but it's super critical that we get a good understanding of who can access what. So, Or, over to you.
Thank you, everyone. It's a pleasure to be here. My name is Or Weis, as you've probably gathered by now. My background starts in the intelligence corps in the IDF. I come originally from Israel. I'm currently coming to you live from London in the UK, but I'm originally from Israel. I served in the intelligence corps as an officer, developer, reverse engineer, etc., etc. I then worked as a first employee in a startup that did containers before containers were a thing, but with a really bad go-to-market, unlike Dockers. Then I worked a couple of startups, was a VP of R&D in a cybersecurity company that caters to governments and like-minded agencies worldwide. Afterwards, I created a developer tools company called Rookout, which is a production debugging solution. And more recently, I've been working together with my co-founder, Asaf Cohen, and a larger team on Permit.io. Both Asaf and I came to work on Permit.io once we realized that throughout our careers, as we were building products, we've been maybe thousands of times or more building and rebuilding access control features to them. And we realized that that's really silly. That's a lot of effort constantly being done and being dumped into this challenge of managing access control. And through that, we realized that this entire space is changing, it's evolving, and it's becoming more difficult as we go, as we move forward. So we wanted to bring an off-the-shelf solution to solve this, but also create open source standards and open source solutions that everyone can use to bring the abilities they need across the stack. And I'm gonna provide details and explanations, both on open source that we've adopted, other projects that we've gained experience with, and we recommend, and also our own open source offering that everyone can use today to build access control of their own into their products or infrastructure. So without further ado, I'll just jump in. And as I said before, I'll be running through these slides. I'll be giving the basic layout of the talk. Then I'll do several demos, and then I'll leave room for questions. So if you have any questions, write it down now, and I'll try to get to all of them at the end of this session. So first of all, I've kind of thrown it in that access control is hard. We need to understand why it's hard and what makes it hard. But maybe to add a little more color on how hard it is, as Asaf and I explored building Permit.io, we looked at the bigger guys as how they're tackling their access control. Asaf previously worked at Facebook, and we saw that they invested basically half a decade, more than 5 years, with a team of 30 people to build their infrastructure for access control. And I think even just that data point kind of gives us a glimpse into what's waiting for all of the companies as we're progressing in building our technological stacks. So now that we kind of do have a clear understanding that it is hard, let's dive into why it's hard. So first of all, there's an infrastructure challenge. In the past, it used to be simple. If we were building just a basic monolithic application, we'd often be able to enjoy some access control that is built into the monolith framework. For example, if we've been using Python, we'd find something in Django or in Spring Framework for Java or in Rails for Ruby. You'll have some basic, usually role-based access control, RBAC capabilities built into the framework. But as we move to microservices, these offerings, these built-in solutions are basically becoming irrelevant, especially if we're working polyglot. So there isn't one specific location that we can have access control baked into. And with microservices, we need to kind of have access control spread about into every little access microservice point. And that makes it both challenging to manage, but also makes it very difficult to build a solution to be performant and highly available. Because if at the beginning um, with basic monolithic access control, we can just query it once. With microservices, we find ourselves requerying the authorization layer, the access control layer for every microservice, because every microservice has to validate the current state. So that can be detrimental and very heavy for the performance of the application. Let's say we're adding even tens of milliseconds per microservice. We'll quickly get to hundreds of milliseconds and even seconds without even doing any performance for the application itself. And that's a real challenge and a real problem. Usually people don't see it at the beginning because you start small. Everyone starts with, let's just have admin and not admin. And then you move to admin, not admin, and super admin. And then you move to access control list, and then role-based access control. And then maybe relationship-based access control or attribute-based access control. And as you move through these different models, you find yourself adding more complexity, more queries, and more workload, both for the CPU and for your data storage that is hosting the relevant data for your authorization queries. So just managing the infrastructure there, just making it scalable, just making it applicable for microservices is super hard. And people don't realize it in the beginning. And that often translates to the pain that I experienced myself, which is rebuilding access control. So for example, in my previous company, through similar challenges, I ended up rebuilding access control 5 times in a company that wasn't even 3 years old. And on average, I see companies every 3 months to 8 months find themselves readdressing access control. And if they don't build their infrastructure right, that means rebuilding all of it. So that can be very painful. And the infrastructure is really the first part. So we touched on the microservices element. Another element is that our modern applications are distributed. They're not just dependent on the microservices in our application, in our infrastructure, but also those in third-party solutions. So for example, if you want to enable billing for your application or authentication or identity management or analytics or anything else nowadays, that is no longer a service in your application. That's no longer something in your database. It's in a third-party remote service. So for example, with billing, we'd be querying something like Stripe or PayPal. So now we have the challenge of working with that distributed data. And some of it, for example, like billing data, is critical for the decisions for the access control layer itself. So we can already see a lot of complexity here. And obviously, if we take distribution up to the edge, if we have devices deployed at the edge and we decide which microservices can talk to them and what those edge devices can do on their own, obviously this becomes a lot more complicated. And this is where a lot of things are going anyway. So that's infrastructure. And the other part, which I started to touch on, is the policy and permissions themselves. So as I said before, everyone starts with a simple model. As I said before, like just admin and not, but you quickly evolve into RBAC, VBAC, and ABAC. And if you don't plan for that evolution, if you don't leave room for that evolution, as I said before, you'll be finding yourself rebuilding from scratch. And that can be very costly. And what people mostly need to understand is while you can start simple, most applications, most companies can't just stick to that simple model. As more requirements come in from security, from compliance, from your customers themselves, from your business development partners, you'll be forced to update your permissions model. So I'll give an example. So in the 5th time that I rebuild access control for my previous company, Rookout, we ended up working with Cisco as a partner, and they started onboarding users to the application on their own. At some point, they came in and said, we want our own back office. We want to be able to manage users on our own as they come in. I looked at it and saw that there's no way in hell that I can refactor the existing permission solution to support 2 back offices. So I ended up rebuilding everything from scratch yet again. And that's not something that I could have predicted. At least it wasn't something that was easy to predict. So these requirements are constantly coming from everywhere, and especially from security and compliance. As events happen, as the company is growing, as you're moving into a M&A, or you're doing an IPO, or you're going into a more regulated field like fintech, healthcare, etc., more of these demands would come in, and most of these regulation demands translate back into access control mechanisms that you need to have in place, which translate into security, policy, and permission models. So that's part of it. And as we said before, there's also the data from third-party services. There are a lot of data sources that are relevant, not just for the application, but relevant for the authorization layer itself. For example, a decision like a policy like only users that have paid for a feature can use it, that no longer resides in your database. That's in a third-party service like Stripe. So now we need to be able to create an experience that is good for both our application and our end consumers, that when someone swipes a credit card in Stripe, we immediately are able to react to that as part of the access control layer. If we don't do that, we'll have either a bad experience or a lousy application. And these are just examples. Every time more things come and add more data elements to them. Time, for example, so we see policies like we want only users during the workday to be able to use this. You're now providing this to a company and they say, we're worried about attacks. We want to make sure that only during the work week, when people are actually working, they should be using the app. If it's not that time, that probably means that it's an attack and we want to block it. You have to be able to mix that in. And it's really hard to do if you have a fixed model that is not flexible. Lastly, the security and compliance elements themselves require checks and balances. So it's not just enough to be able to meet the requirements, we also need to make them transparent to them. For example, and that's also a lot of time deeply coupled with the requirements of regulation. So if you want to be SOC 2 compliant, if you want to be HIPAA compliant, you have to provide that transparency. You need to provide, obviously, the control mechanisms. You need to enforce access, but you also policies for access. But you also need to provide the transparency. You need to provide your security people the ability to look at audit logs. And you need to be able to filter out relevant data out of it so it would be relevant for privacy, et cetera, et cetera. So we're just scratching the surface here, but what I'm really hoping to do is to help you understand that this is a huge problem. And it's constantly becoming harder, especially as you're adding more services, more policies, more dependent parties, and more automation. The more AI you use, the more dynamic flows you have in your application, the more complex your access control layer is going to be. And I think everyone, if you think about the product you're building, you'll be able to have a glimpse into these challenge aspects coming in. You won't know exactly what they are, but you'll surely be able to know that something is coming. So we should prepare for that, to say the least. So when we're talking about access control in our products, in our organizations, we need to understand that it's part of a stack when we're building access control. Basically, everything starts with the physical layer, right? We've got servers, we've got laptops that we're working with. We need locks on doors and passwords on the physical devices themselves to make sure that we have the right control there. Then we move to network level access control. There we see firewalls, VPNs, zero trust networks. On top of that, we had infrastructure level access control. So admission control, for example, in Kubernetes or in another infrastructure management solution. Obviously, service-to-service access control, which microservice can talk to which microservice. And lastly, application level access control, where we basically define which entities can interact with which entities using which features. And that's where most of the complexity is. And everything is kind of ending up trickling to there. But it's all part of this entire stack that we need to be able to build and connect in a secure fashion. When we're talking about building applications, there's another dimension here. So there's the dimension of the stack that we're building for ourselves as vendors or solution providers. And there's the stack that we're providing to our end customers. And those interact. And with both, there's this entire gradual physical to virtual stack. So we have two layers of stack that are constantly interacting, basically defining our space. And kind of like I hinted before, the application level of the stack is constantly becoming more complicated and adding more components to it. It's important also to understand that access control is not just hard, that complexity and difficulty is also translating into vulnerabilities. So in the recent OWASP top 10, the A1 category that was reviewed is broken access control. So managing this incorrectly, misunderstanding how the stack aligns, misunderstanding how your product is going to evolve and the other requirements it's going to have, that is not only translating into hard work that you need to put in to constantly keep this floating, but also it translates in some critical cases into vulnerabilities and actual security events that can break down your application and your security model. So that's also something to keep in mind why we should focus on this problem. So bringing all this together, so we have a lot of sources that create difficulty for this. We have a complex space, a complex stack, or dimensions of stacks that intersect, and there's a bottom line cost that can be very painful. All this boils down into, in essence, us requiring a new way of thinking. We need new tools, we need new best practices, and we need new ways to build software so it won't be as hard, and we won't end up suffering from attacks and vulnerabilities that can be very costly. So first of all, and maybe one of the most important points here, authorization can't be an afterthought. We can't leave it for the last moment. We can't just say, oh, it will be okay. We just need something simple now. We don't need to worry about it. We can always come back to it later. That's going to create problems. While you can address this again, if every time you need to readdress this, every time you need to change this, you have to redesign everything, you're going to have a bad time. We need to plan in advance, not to build everything, but to be able to adjust and evolve the application and its access control gradually. So at each point in time, we can have the right solution in place. We can also use this to think about kind of a roadmap for planning our product. So we don't need to build everything at day one, but we can have a roadmap and we can have standards in that roadmap that will gradually allow us to evolve. And with that evolution, obviously, I'm basically saying that this is an ongoing endeavor. You can't start it now and forget about it, and you can't hope that it will go away. You'll constantly find yourself building this as your application is evolving. So it's something that, unfortunately, you'll have to stick at and constantly work on. But if you plan for it correctly, you can invest little in it at each point in time by leveraging the right tools. And we'll get to those in a moment. And obviously, this affects our customer experience because access control is the doorway to our product. Everyone engaging with a product, both to manage it and deliver it, and obviously to use it, has to go through our access control. So if that part is not working well, everything's not going to work well. Another element that we have here is keeping in mind that authorization is part of a bigger space. It's part of the IAM waterfall. The way I like to think about is IAM is comprised of three layers, three levels within the waterfall. First of all, identity management. So there we have solutions like Okta and Active Directory. This is where we just manage on the organization side the entities and identities that they have, so we can keep track of them. Then as we move into the product itself, we do authentication. So authentication, unlike authorization, authentication is just verifying who's at the door, verifying that the identity that we're interacting with now as part of the identity access management flow is the identity that we think it is. And it means matching it to the identity listed in the organization's identity management. Once we verify that identity, we can do authorization. We can decide what it can do or can't do. Basically, it's kind of elements that trickle down into one another. And what enables them to trickle down, thankfully, are standards, open source standards that are becoming more and more mature. So we have between identity management and authentication, we have SAML and OpenID Connect. And between authentication and authorization, we mostly have JSON Web Tokens, cryptographically signed JSON documents that basically translate the identity into something that the application, and specifically the authorization layer within the application, can work with. Thanks to these standards, now the authorization stack is starting to evolve. So now it has a way to connect. So JOTS, it's important to say, this is a new technology. It got to maturity only in the past 3 to 5 years, depending on how you look at it. And because of that, we can now provide better solutions here. We can build new standards here, and we can continue this trickle down of the waterfall into the products themselves by creating standards for open source. And that's actually one of the parts that I'm most excited about in this space. So it's still a nascent space, but it's evolving quickly. And by creating open source solutions and adopting open source solutions and contributing to open source solutions, we can create new standards here that will tackle all of this pain that I mentioned, that will enable us to have better conversations about it. It will enable us to better design solutions, and most importantly, have a better base ground to build on, instead of constantly rebuilding from scratch and constantly reinventing the wheel. So now that we have a good understanding of the world picture that we're in, understanding of the complexity, understanding where the flow starts and how it continues, let's talk about the best practices that we can harness today using open source solutions, or also building on our own, to make sure that we won't have to constantly rebuild, and to make sure that when we need to update something, it will be easier to do. So the first one, and maybe the most important one that I'll cover now. So if you take one thing out of this presentation, please take this best practice: decoupling policy and code. So the naive approach, and I invite people to look at the Permit.io homepage. We are actually giving examples there on how it looks when you don't decouple policy and code. And what you'll see there is mostly spaghetti code in the application layer itself, mixing up between the application logic and the authorization logic. So you'll have an if condition that at once usually be part of a API gateway, an API route. You'll both be checking that the input is correct, and the permissions for the identity, and that the database is ready. All of them in one if condition. That's a mess. That's a lot of things coupled and cobbled together, and just creates a lot of bad code that is hard to manage. What would happen is that when you need to upgrade this, now you're not only reviewing the access control code, you need to review the entire application's code in order to be able to address this. And that just creates a very complex process. It takes it from taking it as a job for like a couple of days, a couple of weeks, and extends it usually into months, because you need to go throughout your application, throughout all of your microservices, throughout all of the different points, and you need to refactor the code there. The alternative is to decouple the policy from your code. Instead of having that code embedded into the policy embedded into the application itself. We take it out essentially into a separate microservice. And I want to encourage you to actually have it as a separate microservice and not a separate library, because as long as they're part of the same compiled unit or the same build unit, developers will end up mixing between them. We need very strict lines to make sure that these two don't mix. So, because that's a natural thing to do. Like you need, oh, I just need to add another condition here. So instead of adding it in the library itself, like I'll just add it in the if condition that calls that library. That's a slippery slope, and you end up just going back to where you started. But if you have a separate microservice, it's a lot easier to keep the lines well defined, make sure they don't mix, and create a single unit that you can upgrade separately when you need to upgrade your access control. And obviously, when you need to upgrade your application, you can upgrade it separately without having to change your access control layer, because you have two independent microservices. So that's the basic flow here. So we want to create a separate microservice that the other microservices can basically query and ask, can I allow this user to perform this action on this resource? That way, by creating an SDK or creating another kind of intermediate layer, abstraction layer, we can completely clear our application from access control code, except into that separate microservice. We often call it, for those of you that are familiar with the ACML terminology, that separate microservice is often called the policy decision point, the PDP. And in a minute, we'll see options for implementing that PDP through open source solutions. Next step is how we keep that PDP up to date. So we already mentioned that our authorization layer needs access, ironically, to data to make decisions. And that data is now distributed between a lot of solutions that are constantly changing as part of the nature of our application. I gave before the example of a billing solution. We want, when someone swipes a credit card, we want that bit of information to propagate into our decision engine, into our authorization layer as quickly as possible. The best way to do that is to build our authorization layer to be event-driven, meaning when events happen, when data changes, it propagates as events across our system. It's basically best practice for building microservices in general, but it's especially critical for when we want things to be real time. And that's what we want our access control layer to be. In a moment, we'll see an open source solution that enables us to make our policy decision point event-driven and updated in real time. The two following best practices are focusing on the interfaces themselves. And while the first two were focused on how we should build this, what's the baseline for building our infrastructure and our application, these two focus more on the future and how the built application would be used. The main idea here is that we need interfaces that are suitable both for ourselves and the other stakeholders managing the application, and for the end customers. And when you think about this, these are things that you've seen a billion times. And you've probably, if you're a developer, you've probably built a billion times on your own. So things like user management with the ability to assign roles, API key management, audit logs, the ability to see who did what within the system, invites into an application, approval flows, the ability to ask permissions from another user, impersonation, the ability to see the system from the eyes of another user without actually logging in as that user. And the list goes on, emergency access, et cetera, et cetera. So these interfaces, we need to enable them both for ourselves, the developers of the application, the different stakeholders around that. So we have the developers, we have DevOps, we have product, we have security and compliance, but also you'd find that sales, we want interfaces here, and professional services and support. We will need to provide them the ability to work with this layer. We don't have to build everything today, but we want to be able to do so. So when we are planning our solution, we want to leave room, and we enable the flexibility to layer these interfaces on top. So we want it API driven, we wanted to work with the event-driven fashion that we described, and we want the ability to add interfaces as we go to meet the different demands that we have. Lastly, and bringing all of this together, we have a best practice in general in the cloud native space, but I think it's becoming even more powerful now, and that's GitOps. So the infrastructure and layout and definition for everything, and where we keep the policies themselves, my recommendation here is to work with Git or any other source control, but Git is definitely the dominant player in the market. So if we decouple our policy from code, but we still keep it as code, by managing it in a Git repository, in a Git-based flow, we can get versioning, and we can get auditing, and we can get management for the policy itself directly from the Git solution without having to reinvent the wheel. And in general, I think you've got the spirit here. We don't want to be reinventing the wheel. So we can have both the policy, the way it receives events, and how we connect interfaces all be managed together through a Git interface. And that's really how everything here can come together. So now let's dive into the different camps that we have for creating that policy decision point, that policy engine that we mentioned. So as we're in still a kind of a nascent market, there isn't a clear decision now. I can't tell you this is the best solution. This is what is one. There are kind of two camps that are debating, each one kind of presenting itself as the best option, obviously. But they come with pros and cons, and by understanding the differences between them and understanding what you actually need, you can try and choose where to start from. So the two camps are code-based and graph-based. Code-based is very straightforward. If we manage our policy as code, so we're basically writing code, and we can manage that in a Git repository, as we mentioned before, and code is Turing complete. So we can describe any policy that we want. We can describe it as role-based access control, attribute-based access control, everything. And there are some great engines developing today that you can look at, which are open source. Leading the charge, you have Open Policy Agent with its language Rego. In a few slides, we'll look at Rego code and how it basically works and how you can start working with it. But both Open Policy Agent and also work with languages that are derivatives of Prolog. Also, with its language, Polar is a direct derivative of Prolog, and Open Policy Agent with Rego is a derivative of Datalog, which itself is a derivative of Prolog. The advantage of these languages is that they are logical programming languages. It allows us to define rules and have the engine run on those rules for us. That way we can be sure that we cover all of our bases, because it's not like Java or Python or any other functional language where we have to call a function to make sure that it takes effect. With a recursive engine for a logical programming language, the engine itself makes sure to iterate through all of the options. So that's the code-based camp, with logical languages kind of leading the charge there, and with Open Policy Agent really being the main candidate there. It's what really contributes to it is a large community that is supported by the CNCF, the Cloud Native Computing Foundation. It's a graduated project, means it's on par with Kubernetes. But Open Policy Agent is still evolving as everything else in this space. On the other side, we have the graph-based camp here, led by Google Zanzibar, which is a white paper that Google published on how they do access control, and some open source implementations from some other companies. So we have AuthZ with SpiceDB, and we have Ori with Keto, both basically trying to implement the Google Zanzibar white paper, but not fully implementing it yet, but it's on their way. And the idea here is to present our permissions model as a graph. So for example, if you think about Google Drive, we can have a graph. And when I say graph, I mean edges and nodes, not axes. And you can present, for example, you can have one node in the graph pointing to another, pointing to another, pointing to another, pointing to an identity node. And you can think about it, for example, as folders pointing to folders, eventually containing a file. By having your role or your identity linked to the top folder, you can navigate on the graph and see that you can reach the file, and from that you gain access. Obviously, there's advantages and disadvantages with this camp, like with the code-based camp. So it's unlike the code camp, which is kind of Turing complete. The graph-based camp isn't. The graph has to be direct acyclical graph. If it's cyclical, basically you will have a problem navigating the graph, and you might find yourself iterating in it forever. So that's not a good option. So it's really hard to have complex policies described within the graph. So as long as you stick to very basic role-based access control and obviously relationship-based access control, the Zanzibar model would work well for you. But otherwise, it's kind of starts to break. If you want like a lot of attributes, it will make the graph too complex, and navigating on it won't be very performant. Another disadvantage of the graph camp is that you need to manage a huge distributed graph. It's hard to do on your own. It's not like running a simple agent that you can duplicate. And often you'd want some third party to manage it for you. But then you have the challenge of you having a hard time running it locally. So every time you send a query to it, you have to pay latency going to that third-party service. Currently, no one has been able to reduce that to less than 20 milliseconds. But on the other hand, it allows you to manage really large, complex, not complex, but really large, scaled up pictures of data. So for example, if you have millions of users, that's the main reason to use something like Google Zanzibar. That's why Google Zanzibar was invented. It was invented to support the scale of something like Google Drive, YouTube, etc. With the code-based camp, you can basically have all that data managed for the code agent, but it's really hard to load it into the agent, because in the end of the day, you have one process, and if you try to load all of the data into it, you're gonna have a bad time. So if you have a small picture of data, it's better to work with Opal. If you have a lot of data, there's a preference to work with Google Zanzibar.
Just a quick question. Does Google use Google Zanzibar for its own permission models on Google Drive, Google, Suite,
So,
and YouTube, etc.? Do they use it internally?
Yes, they use it internally for Drive, YouTube, and for some elements of Google Cloud. It doesn't power all of Google, but it's probably powering most of Google. There's also other companies using it, re-implemented it, I should say. Airbnb re-implemented Zanzibar on their own, and they call it Himeji. If you Google it, Google Himeji Access Control or Himeji Zanzibar, because otherwise, if you just Google Airbnb Himeji, you just get Airbnbs in Japan, which is kind of funny. And there's also GitHub is also based on a Google Zanzibar implementation. As I said before, Google unfortunately didn't release the code itself, only a white paper. So if you want to use this on your own, I recommend one of these 3 companies below who've re-implemented it. Offz and Ori did so open source, and Auth0 are doing it proprietary. It's important to note, though, that none of these solutions are complete yet. They have most of the capabilities there, but not all of them. One of the capabilities that is missing for some of them, for example, the Auth0 guys haven't implemented reverse indexing, which is one of the advantages that the graph-based camp has on the code-based camp. So with code, you can run it one way, right? You can run it and get an answer to the query. Does Dennis have access to this file. But you can't ask who has access to this file. You can run the code the other way around. With a graph, you can literally navigate the other way around and answer that question. When you're building an application, you almost always have to start with the does X have access to Y? But as you are starting to manage this with security and compliance, they'll quickly need the ability to answer the reverse indices question. And it's really hard to do with just code. So pros and cons. What I actually think would happen, kind of trying to glimpse into the future, I'm no prophet, obviously, but what I think would happen, and also what we're aiming with Permit.io, which kind of combines the two, is to, well, combine the two. Have a big graph in the cloud, also supported by one of these vendors, and have code-based agents at the edge, downloading the relevant data picture in real time into the code-based agents. So you get the highly efficient, zero latency, very Turing complete option at the edge, but you get a bigger complex picture in the cloud that you can run reverse indices on in a non-time critical fashion. And so
by code agents, sorry, quick one. So by code agents, you mean basically bits of code that have object models in memory that contain the relationships that you then query using a programmatic language.
So yeah, something like Opal. So we'll dive more into Opal in a second, but it's essentially, it's a microservice that you load data and code into, and then you can query it.
Yeah, it's quite funny because I was literally about to say, why don't you just put both together, right? Because that has the limitations of the best of and the best of each one, right?
So yeah, so great minds think alike, and that's definitely the way I think about it. But we're not quite there yet. Both the code agents and the graph-based agents, graph-based solutions, are still evolving, and they're still finding the way to be connected. But I do think that this is where this is headed. Another kind of, I think, between the lines lesson that is here is that when you build your access control, you need to be aware that the standards, and as part of them, the requirements are going to change too. So you're building now, you pick a stack, you pick a set of solutions. By the time you finish building, new technologies will arrive to the space, and you'll find yourself thinking, oh, maybe I want those as well. That's why you need to build with the best practices, so you'll have it separate and decoupled enough so you can evolve it gradually when the time comes. More questions here before I dive into Opal, if you already kind of asked something.
No, all good. This is really cool.
Awesome. So Opal, Open Policy Agent. So I already said there are several policy agents out there. Basically, every solution that has something with policies has created a separate agent. I highly encourage you not to adopt these flaky separate agents. We want to kind of consolidate the space. If you adopt an agent that is proprietary and very separate, it will make it harder for you to adopt plugins and capabilities for the standards as things are evolving. So try to avoid that temptation and stick to kind of the leading ones. At least check that there's a significant community behind that agent. I do think that several languages would win in the end of the day. Several agents would win in the end of the day, because that's the nature of modern stacks, right? They're polyglots. Each case and each developer needs as a preference for a different kind of solution or language. Like we have Python and Go and Java, we'll find ourselves with multiple authorization languages, but we probably don't need more now. We kind of want those that exist to evolve. And then after we have kind of a baseline, after it consolidates a bit, maybe we can add more languages. So there are multiple agents to pick from, but like I'd start to look at either OPA or OSO if you want to start with a policy agent of some kind. If you pick OSO, though, be sure to not build it in as a library. build it in as a separate service. I highly encourage you to do so to be sure that you decouple policy and code. So we'll focus on OPA now, on Open Policy Agent. The basic notion here is that we have our own service or multiple services, and it sends queries to OPA to answer access control decisions. Basically, the service asks, can I allow this user to perform this action? Or can I talk to this other service? We send the question to OPA, and OPA returns an answer, and according to that, the service enforces access. So again, talking in PDP in XACML terms, the service would have a policy enforcement point baked into it. That enforcement point can also be in different places. It can be in the code itself as an if condition. It can be as a decorator or some other kind of abstraction in the framework within the service. And it can also be in the service mesh, like in reverse proxy, or in an API gateway. All of those are points where we can apply the actual enforcement, basically control flow. And OPA would be our PDP, our policy decision point. We load into OPA policies in the form of Rego code, which is that language that I mentioned before, and you can see an example for here below. And we load data as JSON documents. So once we send a query in, we can check against the policy and data, which I like to call the kind of world picture, the overall state that is happening. We can ask OPA if it's allowed or not. And then we can manage our code as policy files, as Rego files, and we can manage them as in Git, as I mentioned before. And life is good. It's a good start. A challenge that remains here is how we keep OPA up to date. How do we make sure that OPA constantly has the data that it needs to answer the query when it comes in? But before we dive into that challenge, let's look a little more into Rego code. So you can see that we have what OPA calls rules, also Prolog calls these rules. So each of these statements with a curly braces is essentially a rule. And you can see we have multiple rules here, and we can query OPA for a specific rule. The classic thing to do would be to query the allow rule. So for example, here for allow, we see that the default is false, meaning that if there isn't another rule that will tell us that we're allowed to do something, we won't be allowed. It will be false. The basic flow for allow is if user is an admin. So that propagates us to the user is admin rule. And here we can see that it's the kind of a logical language. We say, if we have some if we have a variable, some option that matches this term, then it means you're an admin. So here we're looking at data. Data looks is a special variable. It's a global variable for the data in the that we loaded into OPA, that JSON documents that we loaded into OPA. So we look into data into the user's object. Within it, we look at specifically the user that was provided as part of the input. Input is also a keyword, a key variable, sorry, in OPA. So we basically expect the query coming from the service to include the user, the identity. This would often come directly from the authentication layer. By the way, if we're providing this with a JSON web token, Opal is also built-in mechanisms to verify the token itself. So we can bring in the token, verify it, and then use it. So we're checking that the user has a role, one of its roles, any of its roles. So roles is a list. Sorry, is a map. Any of its list, any of the members there is admin. If one, meaning if the user that is currently being queried, if it has the admin role as one of its roles, it's an admin. And we can see similar things here for a viewer, and we can see a more complex rule here for granting specific permissions. So we can see a map between the role and the permission itself. Learning Rego can be a bit challenging. It's not like learning Python or learning Java, but once you get the hang of it, you can see that it's a really powerful language. Also, there are other tools that can allow you to generate Rego code for you. So you don't necessarily have to learn Rego, but it's always good to have someone on the team that can understand Rego. And in the end of the day, it is a really powerful language to build complex rules to enforce access control in a very performant way, which is one of the great things here, because as we kind of touched on before, we want to not just have all these features, we want to have them with good experiences. We want the application to be able to answer queries quickly and go into actually doing its work. Let's continue. So now that we understand what OPA is and how we write policies for it, now we need to tackle that challenge of how we keep it up to date. So constantly things would be changing. New roles might be created. The world picture of data might be changing. So we need to be able to update policies and data on the fly in real time. This is where Opal comes in. And full disclaimer, I'm one of the authors of Opal, so I'm kind of biased, but I think it's a good solution. The way Opal works is it creates an event-driven channel to update OPA, and that channel is based on a client-server architecture. Both the client and the server are stateless, meaning that you can scale them out in something like Kubernetes or OpenShift or ECS. They basically create a live channel for you to update your policy agent. So when you work with Opal, you basically get a ready-made container that includes both a client and the OPA agent in it. The OPA agent is just opened directly from the container. So an application or service can query it directly. But the Opal client that resides within that container is now responsible to keep that OPA agent up to date. So when the application comes in with a query, the answer will already, the data for the answer at least, and policies will already be loaded here into OPA. Opal then creates two channels to update the code, sorry, the policy and the data in OPA. The policy source is by default tracked through a Git repository. So we can have a Git repository where we load Rego code into, and when new code is loaded, when a new commit is pushed, basically that webhooks into the Opal server, and the Opal server notifies the Opal client that there's new policies to be had, and then the client fetches them and is updated with policies. So this means that we can just, once we work with Opal and we set up a Git repository, we can just start pushing Rego code or Rego code changes into our Git repository, and they'll immediately start to propagate into the multiple OPA instances that we have. When we work with the Git option, in general, everything with Opal is topic-based. So we can have different clients subscribe to different topics. So for example, you'll have one client that requires the billing policy and another client that requires just the analytics policy. They'll subscribe to different topics. With the Git repository, the folders that contain Rego files, the names of the folders become the topics. So by creating different folders, we can make sure that different clients receive different policies. This is really great often to do some kind of siloing, for example, multi-tenancy. We can create different policies for different tenants, just keep them in different folders, and everything will streamline from there. We can also have Opal track bundle servers. For those of you that are familiar with OPA, there's the classic concept of a bundle server where OPA can poll and intermediately query for new policies. So you can just use those same servers, but now have it real time. You webhook into Opal telling it there's new policies, and Opal will go in and fetch that in real time instead of waiting till the next polling interval happening. The next channel that we have is data. So as we said before, data is distributed between multiple channels. As long as those channels provide events to us, we can have them propagate into Opal. So an event coming from either the application or from one of the sources would propagate into the Opal server, and the Opal server would, through those, according to the topics, would let each Opal client know where the data that it needs is located. And then each Opal client would go and fetch the data. And this is actually a unique part of the Opal architecture. And what's interesting here is that this is really powerful for security and compliance. The data itself never goes through the Opal server. Only the notification that new data is available goes through the server. The data itself is only fetched by each client according to the topic and according to the access that is configured within that client. So that only the relevant microservices, only the relevant policy decision points would be exposed to that data. Because think about it, some of our access control data can be sensitive. It can be PIIs like social security numbers, or maybe even healthcare information, or billing information that we already kind of mentioned. We don't want that information to be duplicated across our application all the time. So by using those topics and by having each client fetch the data directly, we minimize this to a need-to-know basis, which is very important for security and compliance. This also, by the way, enables people working, so permit.io is based on Opal, and we basically host the Opal server for you, and you can deploy the Opal client or the PDP and the edge. So this layout enables us to provide the solution to our customers without being exposed to their data. And this can also mean if you're building a solution for a third party, you can manage the management layer, the administration layer for them, again, without having to be exposed to the sensitive data itself. So that's actually a part that I'm really proud of in the architecture of Opal. Another cool part that we have here as part of the event-driven fashion is that understanding that things have changed happens before the data actually arrives. So everything here is optimized for speed. So first of all, the Opal client receives the event that the policy or data is changed before it actually knows what has changed. And it loads that immediately into OPA. So OPA, as part of its policy, can react to that. So you can say, oh, my state is stale, I'll make a different decision. Oh, I'm missing a part of the information, or some of the information is going to arrive soon. You can make a different policy decision according to that. So that gives you more flexibility and more ability to meet inconsistencies. And because the events themselves are very thin, they don't have a lot of data. It's just metadata, essentially. They can propagate very quickly, and they can be put into effect into the policy very quickly. So that, in short, is Opal. It's an open source project. Even though it's only a year old, it's already being used in production in companies like Tesla, Zapier, Accenture, Cisco, and others. And it has a growing community in Slack that you can join and ask questions in. So this is Opal, and it works really well with OPA. And we plan in the future to support more policy agents with it. Let's now dive into a demo of Opal. So I've pre-recorded this just to make it an easier flow. Sorry, we need to go like this. So when you want to start with Opal, just go to the repository at GitHub, permit.io/Opal. And there's a command line there to instantly install Opal with Docker Compose. So we're doing that now. And Opal is basically running now. And it's getting all of its configuration from this Git repository with the policy, as I described to you before. So we can see that being loaded directly into Opal. and through Opal into the Opal instance that is running with it. Now when we query OPA, we can query OPA directly, the OPA instance that lives next to Opal. We see that it has the data and the policies that are defined in that Git repository. And now when we change that Git repository, we'll see that it could change. But first, let's just work with OPA with the policies and data loaded into it. So here we have a description for different users. They have their IP location and geolocation and different roles. So now let's check for Bob. Let's see if Bob can read the finance object, if Bob can use finance. And we see that we get the result of true. But now we'll change the policy. So to change the policy now, we'll use the Opal CLI. You can push changes into Opal through its API. You can push it as events directly. Opal can use Kafka, and it can use Redis, and it can use Postgres List and Notify. So you can just send events on that channel. But an easy way to work with it is just by using the CLI tool that is provided through the Opal CLI. So we'll just install that from pip because it comes in as a Python module. Opal is Python based, Python Fast API based. So we're installing that the CLI, and then we'll send an update to change the data. We'll change the geolocation for Bob. That's, by the way, an example for another thing that's changing constantly. People are moving around, flying around. So you want that to change in real time. Like if Bob is moving to another country or is now working from somewhere else, or it's just using a VPN, we want that to be part of the, to be aware of it as part of the policy. So we put an update here. We pushed new data, and we can see that that event from the CLI arrived into Opal, and that made and then I'll pause it for a sec so we can look. We can see that we told Opal to fetch data from API.country, and it got the API data from there and loaded it into Opal. And now we'll query again and see if Bob, who is now in a different country, can access, and we can see that the result is false because the data has changed within the policy agent. Because he is no longer in the US, and that's what the policy defines. Now we'll check for something else. If Bob can read an object called bird, and that's just defined in the policy. So Bob can't access bird, but now we'll change the policy so he can. So before we change the data, now we'll change the policy itself. The policy, as we said before, is just managed in Git, in the Git repository. So we'll just be pushing a commit into Opal and through it into Opal. So let's go and change the policy. We can see the policy that is checked out. You can see this rego file. And we just add a new rule. If the user is Bob, this is essentially the equivalent of a super user. We're saying if the user is Bob, always give him access. So we save that. We are now adding it to Git. And we just push it with a commit. We commit it and we'll push it like any changes in code. Git push. And we'll see that Opal would be tracking the Git repository, and it will update the changes. And now when we query OPA, once that change happens, you can see the change arriving. Once that change happens, the policy would be updated, and now we'll get a different result for our query. So now we'll query again, and we see if we can try and access the bird object, not the finance object. And we see that we can. So now we saw quick flow for both updating policy and data for our agents through Opal in a real-time fashion. If you want to see this demo again, it's available in our videos page and on just our permit IO's YouTube. Um, but now I want to show you, so I've kind of shown you how it works like in the infrastructure. I show you how it works when you kind of connect the pipelines. I want to also show you how it looks with building this into an application, what the experience is, that what it means to be event-driven. So I have a demo application here. So I'll just log into it. So it's a really basic to-do application. I can add items, I can check them, uncheck them, I can delete them, very straightforward. Everything works in real time. And I have a back office that I created for this using Permit.io, but you can create this on your own with anything else as well. And here we have basically a map of the roles that we have and their permissions. And for resources and action, so we have the monkey is just an example. I think I'll remove that because it's irrelevant. Don't need a monkey anymore. So we have a board, which is all of the tasks together, and we have each task. Now let's say I don't want to be able to delete tasks anymore. So I apply a change, and immediately when I go into the application, I can no longer delete tasks. And I can obviously change it back, but make it so that I can't update tasks. So I can create tasks, I can delete tasks, but I can no longer update tasks. And this is what it means to be real time. Immediate changes propagate both as data and policy into the application itself. And that's something that you can have in your products as well. And that's part of what we kind of call full stack authorization. We map our application into resources and actions. We can build interfaces on top of that resource and action interface, and then we can manage this in a real-time fashion where everyone can kind of chime in. Another thing that I want to kind of, let's see, how are we doing for time? So we don't have a lot of time, and I want to leave room for questions. So I'll just touch on that as a kind of as a highlight, and if you ask about it, I'll elaborate. Another challenge that exists is syncing front-end experiences to the authorization layer itself. So there's one thing like creating front-end for the authorization layer. That's kind of like the back office that we saw now, but there's also adjusting the front end of the application to meet the authorization layer. So for example, if someone doesn't have access to an interface, we probably don't want to show them the button or the navigation to go into that interface. So the question there is, how do we sync the policy that we have in our backend, in our policy agent, into our front end? The naive approach that most people do is querying from the front end, querying the authorization component in the backend. But that's a subpar solution, because A, it's not very performant. You end up sending a lot of queries to your backend. And B, it requires your front-end developers to learn an entire new thing about your backend, about your policies in the backend. But there's already something that front-end developers are accustomed to and is already used to adjust experiences in the front end. That's feature flag solutions. Things like Launch Darkly, Split IO, Growthbook. So what we recommend as a best practice is to, instead of reinventing, again, reinventing is against the concept here. So instead of reinventing feature flags for authorization, we use feature flags and we sync them to the policy layer in the backend. And for that, we have another open source project called Optoggles. And if you just Google it, you'll find it. So Optoggles, or OP Toggles, is another open source project delivering that exactly. So I think we covered all the points. We kind of, thanks to your question, we also touched on where things are going. It's becoming more hybrid. It's changing. I think what we'll be seeing is policy agents at the edge being synced to a larger graph-based picture in the cloud through an event-driven solution like Opal. And that way we can kind of enjoy everything. And I think this brings us to a great point for asking questions. So you can ask questions now, and you can also find me at all of these places. You can literally schedule a call with me here through this Calendly link, and you can find me in Slack in this link. And you can find me on Twitter and GitHub and other places with that tag. But as I said, I would love to accept some questions now.
Cool. So anybody can put the questions on the chat. I don't think there's any there. I could throw some your way. So in terms of hosting this solution, basically this is because the open source project, right? So companies can host themselves, right? And then you guys provide like the SaaS version of it if they want to basically run it, or don't have to manage the infrastructure and something like that.
Yeah. So both Opal also and Opal, which we kind of I did a demo for, are fully open source. So you can run them on your own, you can scale them on your own, you can add features to them on your own. We have a lot of people, for example, one of the features I didn't really touch on with Opal is data fetchers. You can teach Opal to fetch data from different solutions by implementing simple Python modules called data fetcher providers.
Yeah, I was going to ask you about that, because what about the integrations like with things like Neo4j or Neptune or other databases?
So it's so you basically write a simple Python module that has two functions, fetch and process. Fetch brings in the data, so you get instructions from where to get the data, you act on them, bring the data, and then you process them to be in a fashion that can be loaded into Opal.
And you can also push data back, right? That you change. Is that correct? Cool.
Yeah, you basically can do whatever you want as part of that.
Definitely. Yeah, definitely worth taking a good
look
at.
So we had people implement them for data fetchers for different databases, for LDAP, for Active Directory. And that's also part of the community behind Opal, creating more data fetchers. So a lot of times when you want a data fetcher, maybe someone has already implemented it or something similar.
Have you done integration with Elastic, where the data is actually stored, the graph data is actually stored in Elastic?
So with Elastic, you don't actually need a unique data fetcher, because the API for it is very direct. And Opal comes in with a built-in HTTP data fetcher. So you can basically just give it configuration to query the Elastic's API. You need a data fetcher for something that is not HTTP based or has more complex flows as part of the HTTP.
Cool. All right. Anybody else has any further questions or want to go on mute and ask questions?
I have one question, if you don't mind.
Yeah, please go.
Nice presentation, or it was very interesting.
Thank you.
So nowadays we hear a lot about the shared services that AWS, Google, Azure is building. Are they getting updated, and they will support this kind of model for authentication and authorization?
So authentication, for sure, they're already doing so. So for example, in AWS, you have Cognito, and there's also Google has new solutions around passwordless. They're really gung-ho on passwordless. One of our angels is actually part of the department that's working on passwordless, like in Google. But with authorization, it's something that you need to build into your application itself. So authentication is something at the gateway that you pass through into the application. With authorization, you really need to embed it rather deeply into the application itself and into its data layer. So they might provide solution that will help you manage it. So for example, something like hosting the Opal server for you or hosting PDPs for you. But it will still be up to you to build a permissions model that you need. What I see a lot of people doing, and it's actually a very bad practice, is they couple their authorization model to the IAM model in their cloud vendor. And that's a really bad idea for two reasons. One, as your application changes, it will be hard to stick with that model. It's a model that is built for infrastructure in the cloud, not for a logical application. And two, if you want to move between services or between clouds or between even different solutions within the cloud, you'd find that you are now tightly coupled to services themselves within the cloud. So for example, if you couple access control to buckets in a S3 buckets, when you want to then store your data in a queue, or you want to move it to Snowflake, or you want to move it anywhere else, you're going to have a bad time. So it's very important to have, like I mentioned in this slide, we need access control across the stack. We need infrastructure level access control, but it's not the same thing as application level access control. So it's good to leverage it. I think we'll see more solutions from the cloud vendors to address this, but I think there's a lot of in-depth aspects that are embedded into application that developers and other vendors would have to address separately. Hope that covers the question.
No, you did. And just a follow-up on if you can go into the slide of the high-level architecture that you were showing.
For Opal, you mean?
Yeah, for Opal. So from a security perspective, where do you think if someone is able to breach the system, what is like let's say the game over for a system? If it will be the Opal server, it will be the Opal client. What do you think if someone is able to attack, where they can basically then do everything within the application layer if they breach the system?
So I think both the Opal client and the server are actually not prime candidates for that because of two reasons. One, they're stateless, so they don't really hold any state. In the end of the day, everything that they do is replicated. So even if someone uses them to push a different state, another state can come in and override it. So it's not an ideal spot for an attacker to sit. And the other one is that they're often siloed, especially if you're using topics correctly. You can, by attacking a specific Opal server instance or Opal client instance, you'll be able to cover a set of topics, but you won't be able to cover all of the topics. And everything between the different client and server, there's JSON web tokens on the connections between them too. So it's not like you can just start running amok there. We really put a lot of emphasis into the architecture of security within Opal. If I'd had to point out at places that are, like if I was the attacker, I would target either the Git repository or depending on the layout of the application, one of the data sources. If it's a critical data source and there's, and there you'd probably want to look for weak validation and weak controls. So for one of the main reasons why I encourage GitOps is that because it allows you to layer more mechanics for security and compliance on top of the solution. So you can add tests, and you can add benchmarks, and you can add code review. So that's a really good way to make sure that you have your authorization for authorization, which is a very funny and recursive challenge, managed correctly. With the data, again, it really depends on what the application is and what data it's using. But if it's like, I don't know, you have like one database that has all the roles listed in it and all the permissions, then that's where I'd probably go. And that's where you need to put all of your, not all of, but most of your review flows as part of the solution. The good thing about this, by pushing these, the soft spot to these edges, it's easier actually to audit and easier to manage and track and create those interfaces for the security and compliance stakeholders that I mentioned before. That's actually a benefit of the architecture, I think.
No, yeah, I think the Git, yeah, as you said, it's potentially one of the places that you need to secure better, or you might need to make an eye on it, because there is where you can do anything with it afterwards.
Definitely.
Okay. Interesting architecture in the end. Good. Yeah. Thank you.
You're welcome. Yeah, so if other people maybe want to ask questions, I'll say that again with the Git, here it's really best to stick to the best practices. There's so much content out there to run GitOps correctly, how to connect security into your GitOps flow. So again, there's no need to reinvent the wheel. And that's why we kind of trying to align with it. I see that there's actually another question in the chat from Marcus. Would you recommend some strict push rules for your Git prod branch run? Yeah, so that's definitely what I'm talking about. So one of the most basic GitOps flow is to have separate environments and couple them to different branches or different repositories, depending on your flavor, and having the merge or pull request into that repository be the key flow for your CI. And then at that point, as you move from, for example, from staging to production, you can apply more tests, both for performance and benchmarks, because that's also critical, right? If the authorization layer now is maybe not exposed or vulnerable, but is underperforming, it can still kill the application. We can still DDoS ourselves. If every authorization query now takes, instead of 1 millisecond, a second, the application is essentially dead. So that's also something that we want to verify. And that transition between the branch that represents development or staging to production, that's the perfect spot to apply those tests and to apply those checks and balances before you move on. You mentioned IoT projects, and yeah, I think this can be great for IoT, especially if you have a distributed solution with a lot of devices. The topics mechanism here can really help with that. We're basically coming to the end of our time, but if there's another question, I think we can squeeze one more in, maybe two.
All right, looks like we're good.
Yeah.
Armin, brilliant. Thanks for the presentation, and we'll put the video up. And I look forward to seeing a couple more sessions and maybe on a panel where we can really keep expanding on these topics.
I would love to. And thanks everyone. Thanks for listening to me ramble. Hope you enjoyed it. And again, if you have other questions later, these are the spots you can find me easily. And I wish you all the best, and may all of your wishes and permissions be granted.
Great stuff.